All right, everyone. Good night, everyone. Good night. How is everybody doing?
Good night, sir. Fine.
Okay, good. We're tired, but we keep going. We keep going. We're fast approaching the end of January. Um, Wednesday will be our last class in January, obviously. So, as you can see, time is flying real fast. New Year just start, and you can see we are 1 month in already. Fast approaching February, which is going to be a very short month. It's gonna have a few holidays, so we're gonna lose a couple of classes. Hopefully those holidays don't fall on our class days. So we don't lose any classes. All right. But time is going and it's going real fast. Nevertheless, we're not worried about the time. We're just gonna do what we can and do what we must in whatever time is given to us. All right. So first thing on the agenda for tonight is based on the poll that was posted in the group. I see that not everybody here participated, but I'm going to work with whoever participated. You guys are saying that I should just give you as a worksheet and just give you a 1 day deadline to submit it. That's what I'm going to be working with. All right. Or unless you want me to give you until Wednesday to make a decision. Because Wednesday is supposed to be the test. Wednesday is supposed to be the test.
Say I don't have a problem with doing the worksheet.
Right, so we can use the time to continue doing our teaching because we as a group, unlike the day school students who get more time and the evening class students who are more physical, you guys were significantly impacted by the hurricane. So we would have lost a lot of time. Even with the effort that I tried to make up for the time, it still wasn't enough. So I wouldn't want to use, but I'm gonna do it as a worksheet. I will let you know on Wednesday what time it's going to be uploaded, and then you guys are going to have a few hours to get it done and submit it. All right. So we're gonna teach on
Okay,
Wednesday
so
as opposed to
Sir,
giving you. Yes, miss. Yes,
I,
miss.
I have a class on Wednesdays and I get home.
No, man. I'm gonna upload it on the weekend, man. It's on the weekend.
Okay,
So it's gonna be on a
okay.
right. So
Because
it's gonna be on a Sunday.
okay,
And then
because I'm not able to do it during the week.
no, I understand, man. I figured more or
Yes.
less. So I'm gonna
All right.
upload it on the weekend and then give you until 11:59 to upload whatever you need to upload and then bring it in physically.
Okay.
All right. So that is the plan. That is the plan as it relates to that. No, I did promise you from last week I should have done this. From last week we should have gone. I'm not sure if we went through the method of data collection. I don't think we did, right? So I'm gonna quickly run through it for you. The method of data collection. Oh, sorry. So, like I told you, I uploaded these things to the Google Classroom. I expected some of you guys to kind of follow because it gives you a clear outline. But as you're seeing here on the screen, you're seeing my screen, correct? Everybody see my screen?
Yes, sir.
All right, so we would have already done that. We would have already gone through the introduction, and a few persons would have sent me whatever they had. I would have looked at some of you. Some of you guys, I may have overlooked your message. So if you did send me something and I didn't see it, feel free to send it back to me again. Right? I'm a very busy teacher, and so sometimes I will accidentally overlook your message. But you'll see in here on the screen the outline for the method of data collection, right? And it tells you exactly what is supposed to be inside it, right? It gives you a detailed outline. So let's run through it here. It says your method of data collection should explain these three questions. It should explain how, it should explain where, and it also should explain why you gathered the data that you used for your investigation. You're to use the structure below. As I instructed you, all you have to do is go into the Google Classroom, pull up the document, and follow it line by line, and it tells you exactly what's supposed to be in there. So for number one, you can see that it says that the first thing that should be mentioned in your method of data collection is that you should explain what technique you use. Did you use a questionnaire? Did you use an interview? Did you do an observation? Was it an experiment that you conducted? Did you do an online survey? or did you use any secondary data method? Did you use any data from online? You should state what technique you used. Now, once you've stated what technique you've used, you should move on then to explaining why you chose this method. I've listed out here for you some examples of reasons why persons would choose whatever they choose. It says you should give at least 2 reasons why the method above that you chose was chosen, right? And particularly, a lot of persons will try to use a questionnaire. Not every SBA requires a questionnaire, which means that if you guys reached out to me, right? If you guys reached out to me and you say, sir, this is my topic, this is what I want to do, or this is the method that I want to choose to collect my data, I could advise you, say, hey, maybe this one is better or that one is better. Please note that you can also use a combination. So you can use a questionnaire and combine it with an interview, or you can observe and then ask a few interview questions. So it depends on what you prefer. It depends on which method will best give you the data based on your topic. So for number 2, it says explain why the method was chosen. And then I give you some examples down here that you could choose. You can rewrite them if you want. It's up to you, or you can add on or remove or, restructure or rephrase. Some persons just kind of use about the same thing pretty much. I'm not really going to fight you for that. All right. Then number 3 now, you should also mention within the method of data collection, you should identify the target population. I need to know who you're targeting. Are you targeting students in the school? Are you targeting random persons? Are you targeting persons in your family? Are you targeting persons are you talking corporate persons? Are you interviewing supervisors? Who are these process? It says here that you should describe the exact process. That means whenever I read your method of data collection, I should stay from wherever I am at, and I should be able to read it and say, oh, this is what Tishana did. This is what Antonilla did. This is what Zahenia did. This is what Miss Gentles did. I should be able to read it and I could visually see what the process is like. So inside it, when you're describing the process, you should state in a few sentences how many questions were in your questionnaire, when and where did you distribute the survey, how did you collect the responses? Was it in paper? Did you use Google Forms? Was it an interview sheet that you created, or whatever other methods you may have used? And how long did the collection process took you? All of that should be mentioned in the paragraph. Then number 5 now, you can state any limitations that you may have encountered. Briefly mention any challenges that you may encounter, because some of you guys are writing this before you actually execute the process. But if you have executed the process, right? Sorry, if you haven't executed the process, then you can tell me what potential problems you think you might face. Or if you have already collected your data, then you can tell me what challenges you faced when you were collecting the data. Here are some examples. Some respondents did not return your form. That is normal. Time constraints. Maybe you had problems between school and class time. It took you a longer time to collect the data because you had to go to school, or it was work related, and some of the problems you might have encountered or will encounter. Maybe when you wrote the question, some of the persons who you handed them to, they said that they didn't understand the question. You could mention that as well. And you could also mention the fact that there were some persons who did not answer some of the questions, all of which are all examples of challenges that you might face, but that doesn't mean that you actually face them. And then this final touch, make the section more realistic and professional. So right down here, so now you can see that all of these here should be in your method of data collection. So you should ensure that when you're doing your checkoff, before you submit it to me and say, sir, this is my method of data collection, make sure that you state the method that was selected. Make sure you state the purpose of the method. Make sure that I can see the target population. Ensure that you tell me the sample size, how many persons were in the survey. How did you collect the data? What tools you used? How long it took you? any other reasons that you want to mention, and any other limitations that you might have encountered. All right. When you put all of those little pieces of the puzzles together, you're going to get a method of data collection that looks like this. Now, it doesn't have to be this long. It can be shorter, right? But I just need to make sure that when I read your method of data collection, it has in a little bit of all of what was mentioned above. Right? All of this is in the Google Classroom. I have an example sample here for you, which you can screenshot or you can read it yourself. I have another one down here for you as well, to which you can, I'm not a big fan of plagiarism, but based on the topic that you're doing, you can actually mimic. You can mimic how this is written, and you can write it based on your topic. So that's an example number 2 here for you. I've also uploaded another example here, another method of data, right? This one, number 3, is where we used an interview along with a digital form. Number 2 was where I used an observation along with tallying. Number 1 is where I just use a questionnaire. So if you're the student that's using a questionnaire, you can mimic this one. If you're the student that's using an observation, you can mimic this one. If you're one that is using interview, mimic this one. And if you're using a combination of any two, you can mimic both. One like that, right? So I have 3 samples there for you. So visit the Google Classroom and you'll be able to find this document there. Now, once you've written your method of data collection and I've given you my approval in terms of how it sounds, because I want to give you the marks, But if you don't write a comprehensive description of how the data is collected, I'm only able to give you 1 point of the 2. All right? So rather than getting 50% for this, you better just get 100 and just be good and done. Now, once I've given you the approval, all you have to do after that now, is just go ahead and start structuring your questions, right? When you're building your questions have to be based on the objectives that you're trying to achieve from the SBA. So some persons will use AI to help them write the question. Some persons will write the question, then ask AI to rephrase it for them. And then when you're done, you just send it to me and say, sir, these are my questions. Do you like them? Do you not like them? Do you approve of them? And then you go ahead and hand them out and execute the process, right? You tell me, say you're going to do this, so go ahead and do it. Collect your data and then reach out back to me, all right? So it's press time, guys. It's February. SBA is due in March. So you have to press gas and let me know where you're at. All right. Remember, I can't reach out to you because there's too many of you. So you guys have to reach out to me, especially on the weekend. You can grab me. In the week, sometimes I will overlook your message, but on the weekends you can catch me, and then I'll give you a response. All right. So that's it. Any questions?
Excuse me, sir. You have several students in the waiting room.
Okay. I only see one. Okay, there's another one. All right, so that would be the SBA method of data collection overview. Go ahead and execute your process and send it to me. Yes, go ahead.
Sorry.
Pardon
Could
me?
you please repost the link for the Google Classroom, because I'm not able to
You're not in
access.
it?
No, I'm not.
All right, so I'll have to reset the code and send it. All right, so I'll try to remember to do it after. Send me a message right after the class has been completed, okay?
Okay, thank you.
All right, so that's the little overview that I have to give you. So you can go ahead and visit the Google Classroom and you can get access to the document. All right, so that's it. Any questions? All right, so there are no questions. So can someone remind me of what we are going to be looking at today? What is our topic for our Monday class? What topic are we on?
Factorization.
Okay, we're on factorization. All right, so in our last class, I remember I was looking at the recording today. In our last class, we would have looked at the two subtopics, which are 8CF method and the grouping method, right? And I remember that class because there was a student that said that, sir, you make maths look easy. So that's why I remember that was where we were at. All right. So we would have gone through all of that. So we're going to pick up from the last two. So our objective for tonight is to go through the difference of two squares and to go through the quadratic factoring. That's the objective for tonight. We want to cover that topic or those two topics in its entirety. All right, so let's go ahead and do that. Let's see here. I need to open a whiteboard. Give me a sec. Okay. Live broadcast Zoom has stopped due to. All right. All right. So confirm with me, guys, if you're seeing my whiteboard in 5 seconds, please.
Yes, sir.
Yes, sir.
All right. Thank you so much. Lovely. So let's go ahead and get started. So, give me a sec. Somebody's saying that you're in the waiting room. I don't understand. I'm not seeing anybody in the waiting room. Oh, there they are.
Sir, you didn't change the setting. The board is still accessible for others to draw on.
Oh, so yeah, guys, can you not try not to write on the board, guys? Because I'm not sure how to use this platform and I don't want to use the old one. I need to figure out how to use this. All right, I need to fix up the settings for this. All right, okay, so here we go. Uh, 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 uh. Okay, all right, so our next topic is going to be difference of two squares. Difference. I'm trying my very best, you know, guys, not.
Sir, you never go just finish this algebra,
Oh,
the algebraic thing first.
yeah, that's what I'm doing. Remember, we went
Okay.
through 8CF method and grouping.
Okay.
So we're going to go to this one now, the last two. All right, so here we go. So tonight we're going to be looking at difference of two squares. All right, so for the difference of two squares, that's the topic. Difference of two squares. Sorry for the bad handwriting, guys. I'm trying to access my stylus pen, but I can't find it, so I have to use my fingers to write. All right, so for the difference of two squares. Oh, these persons are late. I can't let you in right now. Hmm. All right, so take down this information for me, guys. The general form for a difference of two squares, the general form for the difference of two squares is x squared minus y squared. The general form for the difference of two squares is x squared minus y squared. Give me a second, guys. Hello, good night. Yes, go ahead. Yes, go ahead. Me in a class. I cannot talk to you right now. I'm in class. I'm so sorry about that, guys. All right, so the general form for the difference of two squares is x squared minus y squared. Full stop. To express, not to express, to factorize a difference of two squares expression, to factorize a difference of two squares expression,
Repeat the last part, sir.
to factorize a difference of two squares expression, we must apply the following steps. We must apply the following steps. We must apply the following steps. Step one. Step one, ensure that both terms are expressed. Ensure that both terms are expressed to a power of 2. Ensure that both terms are expressed to a power of 2. Step 2. Step 2. Open two pairs of parentheses. Open two pairs of parentheses. and insert a plus and a minus, and insert a plus and a minus, in each bracket. Insert a plus and a minus in each bracket. Step 3, final step. Distribute the terms evenly. Distribute the terms evenly. Distribute the terms evenly in both parentheses. Distribute the terms evenly in both parentheses. All right, so those are the steps. Let's run through a few examples. Let me show you what I'm talking about. All right, so in our last class, we would have looked at two types of expressions. The HCF method, where we constantly saw that there was either a number that was common or a letter that was repeating itself. Let me go back to an example of the HCF method to emphasize how this is done. So let's say that you had an example, say for example number 1 here. Let's say the instruction is to factorize and you were given, say something like 12 minus 6ab. And you were asked to factorize that, right? What we would have done last week was that we would have either looked for a common number or we would look for a repetitive letter and we pull it out of the expression. For example number 1 here, you can see that the A is on one side, but it's not on the other side. B is on the right, but it's not on the left. But if you look at the numbers 6 and 12, you can see that 6 is a common factor. So we pull out the 6. 6 into 12 goes 2 times. And the 6 will cancel the 6 on the right and leave us with AB. That's an example of factoring out a common number. In example number 2, you would have had an expression like, say, a squared minus or a squared plus 3ab. And you're asked once again to factorize that expression. In this example, you'll see clearly that there is not a number that's repeating, or there's no number that's common. But if you look closely, you'll see that a is repeating itself here and here. And because we have to factor out the letter that has the lowest power, we're going to pull out the a here, open the bracket, and then we say a divides into a squared, leaves us with a. There was 2a at the start. We put one on the outside, so one is left on the inside. And the a that is attached to the 3ab, that a is already on the outside, so the only thing that's left on the inside is 3b. And your expression would have been factorized. So those are your first 2 examples, which we would have run through thoroughly last week. In example number 3, you'll realize here where we sometimes can factor out both a number and a letter at the same time. So we can factorize both a number and a letter at the same time. So here's an example where we have 3x squared y minus 9xy cube. Now, in this example, you'll see that not only is there a common number, but there's also common letters as well. If you look at the 3 and the 9, you'll clearly see that 3 is exactly divisible into itself and into 9. You'll also see that the x is repeating itself as well, so we can grab one of the x's. Specifically, we want to grab the x with the lowest power, which is 1. And you can see that the y is also repeating itself. We have y to the 1 and y cubed, so you're going to pull out the y. So in this example, you'll see that the expression that we pull out contains both a numerical value and an algebraic expression. Example number 1, we only factored out a number. Example number 2, we factored out a letter. Example number 3, we factored out both a number and a letter. Now let's check it. The 3 that was, so we're focusing on these terms one at a time. So the 3 that was in the first term, it's on the outside. And there was 2 x's at the top. We pull out 1, so 1 is going to be left. And the y that was right there, we pull it out. So only thing that's left on the inside is just the x. Because we pull out the 3, we pull out one of the x, and we pull out the y. So the only thing left on the inside is x. Now 3 into 9 goes 3 times. And the x that was here, we put it on the outside, so that disappears. And there was 3 y's here, and we pull out one on the outside, so only 2 is left. And that expression has been factorized. So that's what we went through last week. We went through how to factorize by using the HCF. So we can easily recognize the HCF because there's always a common number or a repetitive letter that can be used to divide the expression. You can always view this in the recording that was uploaded a few moments ago, but it's not going to be available until tomorrow evening at 7 p.m. All right? Now, why did I go through these examples? Were for the reasons why now I'm going to look at this difference of 2 squares. It's an easy question to factorize, but it's a challenging one to recognize. Just a minute, guys, please. My sincerest apologies, guys. I just keep getting messages from students who are late. Anyways, moving right along. All right, so now that we have gone through that little preliminary there, right? Let's go back to this expression that we have here. So x squared minus y squared, and we need to factorize this. And if you look at it, it just looks blah. It looks very, very blah. There is nothing repeating. And you might say to me, but sir, the power is repeating. Whenever we are factorizing, we cannot factor a power. Notice all the examples that I've done is that I've either factored a numerical coefficient or I've factored a letter. I do not factor powers. So it's not a case where you can pull out the 2. So it's not a case where you can say, oh, sir, I'm going to pull out the 2 and then open the bracket and put x minus y. That wouldn't make any sense because then 2 times x is going to give you 2x and 2 times y is going to give you 2y. That does not give you back the same thing that we had. So there's no way that you could factor out a power. So I'm putting that out there, that if you're going to try to factorize this, you cannot factor out a power. So the steps I gave you earlier, just moments ago, how to factorize this expression is first thing you need to do is to ensure that the expression that you're looking at, they are already expressed to a power of 2. If they are not expressed to a power of 2, then you need to do something to the expression to get it to be expressed to a power of 2. I'm going to run through a few examples with you. So for this example here, you can clearly see that both terms are already raised to a power of 2. That's a clue for you to go ahead and open a pair of or two pairs of parentheses. You're going to ensure that one bracket has a plus and then the other bracket has a minus. And then because there are two x's that are in the expression, you're going to put one over here and you're going to put one over here. And there are two y's also in the expression, so you're going to put one over here and one over here. And that would be your answer. X plus y multiplied by x minus y. Very simple process, right? The challenge with this is recognizing that it's a difference of two squares. Now, you might say, sir, this is easy, man, because as long as them have a power of 2, we're good to go. All right? If that's the case, then look at this one. Let's say you're asked, once again, same instruction. Remember that we're on the topic of factorization. So the instructions are the same, guys. Factorization. So here's the instruction. Here's one. 4x squared minus 9. When you look at this expression and you're asked to factorize, number one, it cannot be an HCF question. Reason being, there is no letter that's repeating themselves, and there is no number that is exactly divisible into 4 and into 9. So we have to cross off HCF as a potential technique. It can't be grouping, because last week we extensively discussed that if it's a grouping question, there must be exactly 4 terms. You're only seeing 2. So by process of elimination, it has to be a difference of 2 squares. But then you might argue and say, then sir, a while ago you just tell me that in order for it to be a difference of 2 squares, all the terms must be raised to a power of 2. And at the moment, looking at it, all of them is not raised to a power of 2. Now, I've had students that do this. 4 squared, x squared, and then 9 squared. That is very, 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 very incorrect. Remember, the rule is not to raise the numbers to a power of 2, but it's rather to find a number that you can raise to the power of 2 to give you the number that was already there. So I'm not going to try to square the 4 and square the 9. I'm going to find a number that if I square it, it will give me 4, and if I square it, it will give me 9. So therefore, the correct approach to this question is going to be to convert the number 4 to 2 squared. I can leave the x alone as x squared, and I can convert the 9 to 3 squared, because 2 squared gives me 4 and 3 squared gives me 9. And so it's the same expression. So now you notice that both terms, or all the terms, are now evenly expressed to a power of 2. You can then go ahead and open 2 pairs of parentheses. Then you make one bracket have a plus and one bracket have a minus. It doesn't matter which one of the brackets have the plus or the minus, as long as one has a plus and one has a minus. Then you're going to ensure that both brackets are evenly distributed with the terms that are available. So here you can see that there are 2 2's. So you're going to put one over here and one over here. There are 2 x's, one over here and one over here. And there's 2 3's, one here and one here. And your expression has been factorized. All right? Any questions so far?
Yes, sir.
Go ahead.
Can you please tell me how you get the 3 square?
3 squared is 9. I found a number that I can multiply by itself to give me 9. And that whole number that is 3.
Okay, sir.
All right, let's do another example. Because like I said, guys, when I'm doing it, a lot of persons be like, oh, this is very easy. The challenge is not in doing it. The challenge is recognizing that this technique is what you should be doing. For example, let's say I give you one like this then, right? Remember now, let's say I give you something like, let's say I give you something like 9 y squared minus, let's see, 9y squared minus 25. Something like that. 9y squared minus 25. Yeah, 25t squared. Now, if you look carefully, you'll notice that there is nothing that's repetitive. There's nothing common and there's nothing repetitive. There is no number that can go into 9 and 25 exactly. And the y is on one side, but it's not on the right. The t is on the right, but it's not on the left. So there's no 8CF technique here. Now, once you have eliminated the fact that it may be a 8CF or it's a grouping, once you've eliminated those two options, then your next option is to identify the process of difference of two squares. Somebody has a question? Okay. So here, I need to find a number that I can square to give me 9. And as we had suggested here earlier, that is 3 squared. Y is already raised to a power of 2, so I can leave that one alone. 5 squared gives me 25. And then I can leave the t squared alone. Remember, the objective is to ensure that every single term in the expression is raised to a power of 2. So here, once we have successfully raised everybody to a power of 2, we can open a pair of parentheses. We can insert a plus in one and a minus in the other. I generally just put the plus on the right and the minus on the left. Sorry, I generally put the plus on the left and the minus on the right, but you can put the minus on the left and plus on the right. It doesn't matter. All right? And so once we're successful in doing that, we ensure that there's a 3 here and there's a 3 here. There's a y here and there's a y here. There's a 5 here and there's a 5 here. And there's a t here and there's also a t here. All right? So all brackets have 2 of everything. So the answer then that you'd get is 3y plus 5t and 3y minus 5t. And that's it. Okay? That is how we work the expression. All right. Any questions? Before we move on to some more challenging ones. Is everybody clear?
Yes, sir.
And now there are some tricky ones. There are some tricky ones that you need to be very mindful of. And these tricky ones, again, they're not tricky in terms of how to get it done. It's just tricky in terms of the recognition. So here I'm going to give you an example, right? I'm going to give you an example. Oops, let me just try to, right, here we go. So I'm going to give you an example, right, that has a combined method, right? And it's easily, it tricks people all the time, right? Normally when it's worth 2 marks, majority of students I know always get 1, right? When I was doing it, when I was learning it, I never got it right. No matter how hard I try, I never got it right until I start recognizing. Somebody's mic is unmuted. Daniela, your mic is unmuted. Daniela, your mic is unmuted. Okay. She probably is not near. Okay. All right, here we go. All right, so here's an example, right? Here's an example. We have same instruction, guys, factorize. We have factorize 4a squared minus 16. This one is a tricky one. It's a tricky one because when you look carefully now, if you look carefully, all right, so what flies over the heads of most of my students is once they start working these types of questions, they get caught with the idea of getting the numbers to be raised to a power of 2. So here's what happens now. They're going to see the number 4, because obviously you're going to do a lot of these questions. So when they see the number 4, they're going to immediately recognize that 2 squared gives us 4. A is already squared, and right away 4 squared gives you 16. And everything looks nice. Really, really nice, right? So we have 2 squared, a squared minus 4 squared. And it's like, okay, good, we get it right. This is what sir say I should do. Then they go ahead and they open 2 brackets like that. And they put a plus here and they put a minus here. And I'm nice and I'm comfortable. And they put a 2 here and a 2 here. They put a here and a here. They put a 4 here and a 4 there. And them feel comfortable and them gone and them say, yes, me get it right. Now, it's not a case that they haven't gotten it right. It's just that the question is incomplete. It's incomplete because when you factorize an expression, there cannot be anything that's repeating. You notice that even in the answer that that student would have provided, still 2 can go into 4. So whenever you have factorized an expression, if you notice that here, nothing is repeated. It's 3 on the left, 3 on the right, y on the left, y on the right, 5 on the right, 5 on the left, 5 on the right, t on the right, t on the right. There's nothing that's repeating in either bracket. So it's not like you can take up one of the bracket and pull out something that's common. Nothing is common in the bracket on the left. Nothing is common on the bracket on the right. But if you look at this expression here, you realize that you can still pull out a 2. And we don't want that because this would be what is called an incomplete factorized expression. Now, let me show you exactly what flies over most of you guys' head, right? And when I say most of you, I'm talking about students in the past. Remember, when you're factorizing, you have 4 techniques that you're working with. Thus far, you've only learned 3 of the 4. You're going to learn the other one tonight. So remember that when you factorize, when you see that topic factorize, first thing you need to look for is there something that's repeating itself? If you don't see anything that's repeating itself and you don't see 4 terms, there's a high probability that the expression is a difference of 2 squares. But sometimes you can have a difference of 2 squares that's hidden beneath. If you look at the expression, do you recognize that the letter, the number, not the letter 4, but the number 4 is common to 4 and 16? So if you see I pull out the 4 here, let me just grab a pen here. If I pull out the 4 here and I open a bracket, notice what's left is a squared, and then now I'm going to have 4 into 16 goes 4 times. So now I've completed what is called the 8th CF section of the problem. This is combined. So it's an 8th CF question combined with a difference of 2 squares. So then you might ask me, sir, where is the difference of 2 squares? I don't see it. So the difference of 2 squares here, guys, is right in the bracket here. Notice that this number 4 can be rewritten as something different. So I can go ahead now and I can rewrite this expression here, 4, and I can go ahead and say a squared, and I can convert the 4 to 2 squared. And now, inside the bracket, keep your focus on the bracket. The 4 on the outside, this 4 here, don't pay it no mind. We already factor him out. So I'm good. He just stay outside and behave himself. Inside the bracket now, we have the 2 terms that are raised to a power of 2. We can go ahead, open here, 2 brackets, insert a plus in one and a minus in the other, and place a here and a here and a 2 here and 2 here. And that's the answer. Now, this and this is not the same. If you look at this expression here, in that bracket, you can clearly factor a 2 out again. And in this bracket, you can factor out a 2. But in this bracket down here, inside here, there's nothing to factor. And there's nothing in this bracket to factor. So both answers are correct. It's just that if I give you 2 marks for a question like this, the person who approached it this way would only get 1, and the person who did it this way would get the full 2 marks. All right? So it's not incorrect, it's just incomplete. All right? So that's what you need to know. So you have to look out for them tricky little examples here. They do pop up occasionally, and you can easily lose a mark or 2 for incompletion. Okay? All right. So take off that example. And if you have any questions, the floor is open. And in the meantime, what I'm going to do is just have you try one similar to this. Go ahead and factorize this for me. So go ahead and factor it. Remember, we are not going to tell you if it's difference of two squares or not. It's going to say factorize. It's not going to say factor the difference of two squares. So don't expect that. All right, so go ahead and try this one for me. 3x squared minus 27. Go ahead and factorize that. I'm just giving you just a simple, maybe like a minute and a half. All right. Hopefully you recognize that it's another example of a combined factoring technique. You will recognize, unlike the first example here, where you could perhaps change the 4 to 2 squared and change the 16 to 4 squared, this example, even if you tried, you wouldn't be able to find a number that you can square to get 3, and you wouldn't be able to find a number to square to give you 27. So even though they are similar questions, this one you may be able to get away with it, but this one you would struggle, because with this one over here, you could actually find a number to raise to the power of 2 to get 4 and 16. But with 3x squared minus 27, you are unable to do that. So here, what you have to do is pull out the 3. Hopefully this is what you did. Write back your x squared, and 3 into 27 goes 9. And then if you take a good look at what is in the bracket here, you'll recognize that this 9 is a number that can be re-expressed as a power of 2. So we can go ahead and say 3 open bracket, x squared minus, we can change the 9 to 3 squared. And if you look in the bracket, both terms are expressed to a power of 2. Therefore, we can go ahead and say 3 open bracket, put a plus in one and a minus in the other, put a x here and a x here, and a 3 here and a 3 there. All right, and that would be the complete factoring method. All right, so that is what a difference of two squares is. It's not a very difficult question to do. It's just, for majority of the most students that I've ever taught, it's the most challenging technique to identify. It's like with the grouping, where you know see 4 terms, and with the 8 safe, where you can clearly see that there has to be something that's common or something that's repetitive. With the difference of two squares, if you're not accustomed to this type of technique, it can be an easy question for you to give up and give away the marks. And it does come with 2 or 3 marks, depending on the complexity. All right? But that is the process. All right? So let's summarize this before we move on to the final technique. If you recognize, or for you to recognize a difference of 2 squares, there cannot be anything that's, well, we can't say that. There can be something that's common. But for the easiest way for you to recognize the difference of 2 squares is to recognize that. So number one, get used to these numbers: 1, 4, 9, 16, 25, 36, 64, 81, 100. You see them numbers there? they're very special numbers in mathematics. We call them square numbers. So whenever you see them numbers, are combined together in one expression. That's one clue of recognizing it. But most importantly, the difference of two squares usually has a minus sign, and it also has a term that's squared. Now I'm going to show you an example that if you don't pay very close attention, it will trick you and make you think it's a difference of two squares. Have a look at this example. So this example down here can trick you very easily, and you'll think it's a difference of two squares. So here, instruction says to factorize, and here it is. It is 9x squared minus 15. This can easily trick a lot of people, because if you look carefully, I can change the 9 to what? 3 squared, and the x is already squared. But when you reach right here, so you're going to find out, so you don't have a number that you can square to get 15. 3 squared is 9 and 4 squared is 16. So there's no number that you can square, so you're pretty much stuck right here. So you can have expressions that will come across as a difference of two squares, but you have to pay very close attention. Remember, for it to be a difference of two squares, all the numbers must either be expressed to a power of 2 or they can be expressed to a power of 2. For example, here, only the numbers on the left can be expressed to a power of 2. The number on the right, which is 15, cannot be expressed to a power of 2. There is no number that you can square to get 15. So then the instruction is still to factorize it. How do I factorize? Because if you look at the 9 and the 15, 3 is exactly divisible into 9 and into 15. And if I pull out the 3, I'm going to end up with what? 3x squared. And if I put 3 into 15, I'm going to get 5. And that will be my final answer. All right? But you have to get accustomed to the types of expression. And the only way you can get accustomed to it is obviously through practicing. Okay? All right. So that takes care of that particular topic. For that is the third technique. We're going to look at the final method, which is the quadratic factoring. All right? We're going to try to do a couple of examples. We may go over 8:30 because I want to ensure that I cover a couple questions well, right? So that there's no inconsistency when it comes to this. All right? The floor is open. Do you have any questions?
Sure.
No, sir.
Does it really matter if the plus is before or?
No, it doesn't matter. As long as one of the bracket has a plus and one has a minus, we're good to go.
Okay.
All right, so we're going to close off this section right here, and we're going to go ahead and look at quadratic factoring. Quadratic, quadratic factoring. All right, now take down this information from you guys. So the topic is final technique, quadratic factoring. The general form for a quadratic expression, the general form for a quadratic expression I'm going to write it on the screen. Ax squared plus or minus bx plus or minus c. This is how every quadratic expression looks. It has a square at the front. Then it has a term without a square. And then it has what is called a constant. So this is how a quadratic expression looks. Let me give you an example of what it looks like. 2x squared plus 5x plus 3. That's an example. of a quadratic expression. And if you look very closely, you notice that it doesn't look like any of the other expressions that I've written on the board. It definitely isn't a difference of two squares, because if it's a difference of two squares, why do we have three terms? So we can definitely eliminate the difference of two squares. Another expression that we can eliminate is grouping, because we distinctly mentioned last week that when it comes to grouping, there has to be exactly four terms. And there's only three terms in this. So we can safely eliminate grouping. And maybe you could think it's a HCF method, but the problem is that there is an X here, there's an X here, but there's not an X here. So there's nothing that's common. There's nothing that's repeating itself. So therefore, by process of elimination, there's nothing repeating itself. HCF is gone. It is not four terms. Grouping is gone. And it's not a difference of two squares because there are three terms. That means by process of elimination, if there's four factoring techniques and you've eliminated three of them, then the only other option is the only deduced option left is to say that the expression is quadratic. All right. So get used to seeing this type of expression. All right. So now what I'm going to do is I'm going to lay out some steps that you need to follow. I'm going to lay out some steps that you need to follow in order for you to get to your answer. I'm wondering if I could pull up a quick notepad here. Okay. Is this a notepad? I'm not used to this one, you know, guys. So forgive me if it's in my way. I did edit clear page. Whoa. No. Okay. All right. So can I write on it? I don't even know how to use this. I don't know. Can I write on it? Text. Oh, I can write. Okay. Oh, I can't. Let's see. Oh, it's so big. Guys, forgive me. I'm not used to this. I'm not used to this.
Sir, just dictate.
You're teasing me to just dictate, not true?
Yes,
Oh,
sir.
I would love to write though, honestly. All right, so it's me can write that's all. Let me see. All right, so let's hopefully it works. All right, so these are the steps for quadratic factoring. So steps for quadratic factoring. The steps are going to seem quite long, but like I've told all my other students, that when I give you all these steps, after you reach the first four steps, you don't even write two lines on the paper. But you're going to see still. You're going to see. So number one, let's write it down, guys. Number one. First step is to form the product. Form the product AC. I'm going to let you know what that means in a second. Form the product AC. That's the first step. Form the product AC. Step two, we're going to list all possible pairs of factors of AC. List all possible pairs of factors for AC. Step three, select the pair of factor that will produce the middle term if added or subtracted. So select the pair of factor that will produce the middle term if added or subtracted. 4. Substitute. Oh, you guys are not seeing it, not true? All right, so I guess this is gone. All right, let me see if I can delete this. All right, that's
Put it
gone.
back behind it. It makes it easier to see.
Put it behind it. You can see it now?
Yeah. When it was behind it, the words were showing clearer.
Oh, well, it gone. Yeah, me delete it. Hush. Substitute. I'm not used to this, guys, so bear with me. I have to go train. Substitute the middle term with the chosen pair. And the final step is to factorize by grouping. If you can catch on to that, guys. I'm going to place it over here. Well, yeah, catch on, man. It's bad, man. I've always used an external app, So I didn't know that Zoom was this advanced. So forgive me. All right, I want myself. All right, so those are the steps for the quadratic factoring. Step 1, you're going to form the product AC. Step 2, you're going to list all the possible pairs of factors of AC. 3, you're going to select the pair of factor that will produce the middle term if it's added or subtracted. Number 4, you're going to substitute the middle term with the chosen pair. And number 5, you're going to factorize by grouping. Looks like a lot of steps, but when I'm doing it, you realize that we're going to get to step 3 and step 4, and only one line, maybe 2, will be written on the screen. All right? So we have 80 minutes. Let's see if we can do at least 2 or 3 examples applying these steps. All right? After the second example, you guys will start to catch on to what's going on. All right? Are you ready? Let us go. All right, so the first thing, I'm going to keep it simple, right? Let me keep it simple and then start to increase the numbers. So here, first instruction is to factorize. Remember, ladies and gentlemen, when you're asked to factorize on a paper, they will not specify and tell you to factorize by grouping, factorize the HCF, factorize the difference of two squares, factorize quadratic. You're just going to see one instruction, factorize. And your ability to identify the different techniques are going to be. All right? We're going to factorize. Is there someone writing on my screen? All right, so factorize. Here we go. So very first example, we're going to write it right underneath the steps so we can see them. X squared plus 4x. Oh, not 4-3, 4x. Plus 3. Very simple one. All right, just to get the point across. Now, in this step here, you will see where I say to you, form the product AC. Does anybody know what the word product implies?
To multiply.
To multiply. The word product means to multiply. Well, it really doesn't mean so it means multiply, but the correct definition for product is the result of when you multiply two things. The product is the end result. So if I ask you what's the product of 2 and 3, technically I'm saying, tell me what is the result when you multiply 2 and 3. So oftentimes us math students, math teachers, we are told that product means to multiply. It implies multiplication, but the actual definition of a product is the result of when two or more things are multiplied. So, I mean, I'm very meticulous with when I'm wording my stuff, because I know how information can mislead you if it's not stated correctly. So when we say form the product of AC, it means I want you to take the value of A and I want you to multiply it by the value of C and tell me what the result is. So you ask me now, then sir, AC, where is A, where is C? If you look carefully, let me just scroll back. Let me see here. Boom. Where is it? Okay, here we go. All right, so this is it here. All right, good. So if you look back up here, you'll recognize that the number that is in front of x squared is A. And if you look very closely here, that the term at the end here is C. So what step 1 is saying is that we should take the number that's at the front, which in this case is 1, and we're going to multiply it by the term at the end, which is going to be 2. So that's what it's saying. So it's saying that we should go ahead and multiply 1 times 3. That's what it's saying. It's what some of you guys, some of high school students will know this as the AC method. That's what they call it in high school. But I don't really call it that. I know it's called that most places just to make it easier, but the correct name is called quadratic factoring. So you go ahead and you multiply A times C. Now, like I said, when you get these questions, you're not going to see the 1 there. You're just going to have to know that there's a 1 there. So when you don't see a number in front of a variable, the number that is understood is 1. We're going to go ahead then and say 1 times 3. Let's write it down. 1 times 3. That's going to give us 3. Now, 3 isn't really a challenging number. It's not going to really pose any threats to you. It's a prime number. So really and truly, it only has one factor, which is 1 and 3. Right? You're going to get bigger numbers like 6 that has 2 pairs of factors, 12 that has 4 pairs of factors, 24 that also has 6 pairs of factors. So it depends, right? Sometimes you get a nice, easy number like 3, and sometimes you get a number like 48 or 60 that has several factors. All right? So step 1, we have formed the product AC. The product of A here, which is 1, and C is 3. Now, step 2, we are to list all the possible pairs, right? There isn't a lot of pair. In fact, there's only one pair, and that's only 1 and 3. Only 1 times 3 can produce the product 3. So we have listed all the possible pairs. Step 3, we're going to select the pair that will produce the middle term. And the middle term here is going to be, let me grab a different color ink. The middle term here is going to be 4x. So what we're aiming to do here is that when we make a choice, we need to choose so that the pair that we choose will give us back the middle number there, or the middle term, right? In this case, there's no choice to make because we only have one pair. And if you look carefully, 1 plus 3 will give you 4. So whenever you have more pairs, then you're going to have to look carefully at what to choose. But here, there's no choice to make because there's only one pair. All right? So we would have completed step 3 here. Step 4, substitute. This word substitute means to replace. You're going to replace the middle term with the pair that you chose. So we chose 1 and 3 as our pair. That means we're going to bring back down the x squared. We're going to kick this away. Excuse. And then take them 2 here right here, so, and put them in the middle. So we're going to have plus 1x plus 3x. And then we're going to bring back down this 3 right here, plus 3. So if you notice that 1x plus 3x will give us 4x. So it's the same expression. Right? So what we did is that we moved the 4x, we substituted the 4x with 1x and 3x. Because 1x plus 3x gives us 4x. So it's the same expression, it's just expanded. And then now step 5, we're going to factorize by grouping, because we did this last week. We learned that when it's a grouping question, we know that there's going to be 4 terms. So we can put this into groups of 2 here, and here into groups of 2. And then we're going to factorize by grouping. So in the first bracket, you'll recognize very easily that the common factor from the first bracket is going to be x. When I pull out the x into x squared goes x times, because we know that there's 2 x's at the top. We'll put one on the outside, so one is left on the inside. And the x that was right here, it's already on the outside, so only 1 is left. Close the bracket. Pull out another factor. On the right, you can see that there's the number 3 that's repeating. So pull out the 3, open the bracket, remove the 3, we end up with x. 3 into 3 goes 1 time. Now from last class, we discussed that how do you know when you're on the right path? How do you know that you're not doing foolishness? Is when the 2 brackets end up being the same. So because the 2 brackets end up being the same, we end up with x plus 1, right? Because they're both the same, so we can just eliminate them, right? Because you're basically common factor, and what is left is going to be x plus 3, all right? And that expression has been factorized, right? It has been factorized.
Sir,
Yes, go ahead. Question.
just to make sure I understand this before you move along, the second part of your question, the 3 into 3x, because 3 into 3 would give you 1x. That's why I didn't write the 1, because x
Right,
already means 1.
yes, because the number in front of x is understood to be a 1. So if you want to write the 1x, it kind of looks weird, but if you want to write the 1x, no problem.
Okay, so I just wanted to make sure.
Yeah, man, no problem. So we're going to close off here. Oh, so this is how I do the line. Oh, that's nice. Okay. So let's grab this, then close this off here. Okay, this is dope. All right, nice. Wicked. Guys, so me I learn. You can't clap me. I'm not hearing any applause, you know. All right. So me I learn. Thank you, Galia. Thank you, Abigail. Me I learn, man. So catch on, man. So start some advanced stuff. Hold on, let me see if we can get one axis. Play around. Oh, wicked. Wow, look on that. We can use arrows. See that, guys? Jesus. Now, bad teacher now, you know. I see we can use arrow and point now, you know. Hey, chut. Bop. We can't clear the page. Oh, Lord have mercy. Hey. Ay. What is going on? Get away. All right. Boss, you have a boss, you know. All right, come in. Ready again. We'll do one next example. I know time is up, but let's squeeze in another example. All right, so let's say that you were asked to save instruction, factorize. Let's do. Oh, we could do the one that we had up here, right? Oh, that's dope. This one, right? 2x squared plus 5x plus 3. Let's do that one. It's dope. All right, so 2x squared. Oh, come on. 2x squared. Don't embarrass yourself, Mr. Pierre. Them just clap you, so don't embarrass yourself. Plus 5x plus 3. All right, so now we're going to go ahead now and we're going to complete the process again. Right, step 1 is to form the product. AC. Let me grab a red here. Boop. And I like how that line will look. So and so. Right? So now this is going to be 2 times 3. And that's going to be 6. Now 6 is a bigger number than 3. So it's going to have more factors. Right? So now we can look now that 6, we have a pair of numbers. We have 1 and 6 that can multiply to give us back 6. And we have 2 and 3 to give us back 6. Now, here's the thing now. We have a problem. You know? Here's the problem we have. If you look carefully, both of those pairs can give you a 5. Sir, what do you mean it can give you a 5? How? Because if I go ahead, let me just see if I can zoom up here on this. Zoom up on this. Come, Mr. Peart. All right. Good. Let's look at 1 and 6 for a second. right? 1 and 6, 2 and 3. So we say 1 and 6, right? 1 and 6 can multiply to give us 6, and 2 and 3 can multiply to give us 6, right? However, look, if I go like this, right, and I put a plus in front of the 6 here and a minus here, 6 minus 1 is 5. All right? And a 5 more one back, Remember, look up here so now. Watch me goes, oh, what is going on? Oh, so you move this. Hi. Wicked. This body, man. Hey. All right. Get yourself, Mr. Pierce. Let me never know we could have. Whoa. Wicked. Come. Get a hold of yourself, Mr. Pierce. All right. So remember now that here, so I'm looking back for 5, right? 5 me I look back for now. So can we zoom up now? Right, so. Boom. So remember now, if I put a plus in front of the 6 and a minus in front of the 1, I can get back 5. Right? But if I put a plus in front of the 2 and a plus in front of the 3, I still get back 5. So if both of them can give me back a 5, then which one is the right one? Well, in this case, you have to choose the one that not only should it give you back 5, but you can also multiply it to give you back positive 6. And clearly, if you go ahead and you multiply negative 1 by 6, it will give you negative 6. But if you multiply positive 2 by positive 3, it's going to give you positive 6. So you have to choose the one that not only will it give you the middle term, but it must can multiply back to give you back AC. I'll give you back the product of AC. So in this case, my choice is going to be 2 and 3. Of course, you're going to say, then, sir, what if I make a mistake and choose the wrong one? What is going to happen? You're going to be marked down for choosing incorrect. In fact, you say if you choose the wrong term, at any given point, if you choose the wrong term, you're not going to be able to complete the factoring. I'm going to show you what's going to happen to you if you choose the incorrect factors. Let's go ahead and choose the right ones. So we have 2x squared here, right? And remember now, remember step 3, we're going to kick with this, excuse me. Move that. Hold on there. Watch it. Look now, look guys, look. Look on my body, I'm going to just move it. Oh Lord Jesus, I wrong something to move. Chai. Oh Lord. All right, anyways, we're going to just move. we're going to move the 5x, guys. So I get ahead of myself. We're going to move the 5x. And we're going to put the 2 here. So we're going to put plus 2x here. And we're going to put plus 3x here. And then we're going to put back the plus 3 here. So look carefully now, But I get confused now, Look, you see the 5x that was here? This 5x here, move it. Like for them saying in step 3, substitute the middle term with the chosen pair. So those are my chosen pair. I'm going to move the 5x and I'm going to put the 2x there. I'm going to put the 3x here. So that 2x and that 3x is from right here. So. And then now I'm going to put back the plus 3 at the end. And I'll place them into groups of 2. And I'm going to factorize by grouping. Now look at the first bracket. Do you notice that the 2 and the x is repeating itself? So I'm going to grab 1, 2x. Now, the 2 that was up top in red, this 2 right here, so notice I pulled it on the outside. And there was 2 x's here, and 1 is on the outside, so 1 is left here. And then we know that 2x into itself will go 1 time. When you divide something into itself, it goes 1 time. Now, on the bracket on the right, notice that the x is not repeating, but the common factor there is 3, so I can pull out the 3. And 3 into 3x will go x times, right? Just as the student asked me earlier, sir, can I write the 1? If you want to write 1x, you can, but it's weird, right? To have 1x, which actually means x, makes no sense. So we just write x, right? And then 3 into 3 goes 1 time. Oh, why do I have a 3 there? 3 into 3 goes 1 time, all right? And how do you know you're not doing foolishness? Is when the 2 brackets are the same. So you end up with x plus 1, and you end up with 2x minus 3, or 2x plus 3 in that bracket here, all right? And that is how you factorize a quadratic expression, right? They're much more challenging. Well, when I say challenging for CXC purposes, it really now go past that. But usually when I'm teaching this topic, I have at least 3 or 4 or 5 examples. But because we have exceeded the time for the class, right? When we come back on Monday, we will go through a few more examples, right? And close off it and then move into another topic. But for now, you have the tools to use. Now, to support you, I'm going to post a link shortly, right? I have a video that I did about 2 years ago, right? That explains this. So I'm going to send it to you. And for those who would like to go ahead and watch that very short video, it's about 40 minutes long. So it's not long, right? It explains this concept that was just taught in a little bit more depth. So you can check it out. It has a lot more examples as well. So I have 2 videos for it. One that explains the theory and the other one that does practical examples. I'm going to send those shortly as soon as I'm off the meet. All right. But for now, this is the end of tonight's session. All right. So if there aren't any questions, you guys can, and that would be the end of the session. And I'll see you guys on Wednesday, where we have another session. Remember that I'll be uploading the worksheet over the weekend for you to access and complete and submit to me. Okay? All right. With that said,
Sir, please remember to send the study guide.
the study guide.
Sir,
Oh, which study guide that?
fetus.
Okay. All right. Study guide for the test.
Question 2 pertaining to this expression that you just did. They use letters as well?
Letters, what do you mean? Like,
Yeah, like if you have like 2, like n square minus n minus 20.
yeah, man, they use various letters and not just X alone. So you can have something like 3.
No, I'm talking instead of numbers.
No, man, no there. No there.
Oh.
Just as you see it here, number and X with a number. Yeah, same way. Nothing different.
Okay.
Nothing like that.
All right, thanks.
All right, no problem. All right, guys. With that said, have yourself a blessed evening. Be blessed. Take care. Good night.
Thanks,
Good
everybody.
night, everyone.
No one is writing. No one is writing, so I'm going to close the class. Good night, Miss Johnson.